So we have a system for using arbitrary escrows with the ERC-8004 validation registry. And I'm just going to demonstrate a simple flow of Alice buying something from Bob, demanding a validation from Charlie above certain score. So first, Alice constructs her demand, demanding the validator, the validation registry, and the minimum score. And then she deposits something into escrow. And in this case, we're using the ERC-20 escrow obligation, but we support all the different common ERC tokens like ERC-721 and ERC-1155 and arbitrary bundles of these. And in fact, tokens aren't the only thing you can escrow. You can escrow any on-chain action that you can promise to do in the future. So you could escrow, for example, the making of an attestation, or you could escrow voting a certain way in a proposal. But anyway, Alice deposits her escrow with her demand, and that transfers the tokens to the escrow contract. And then Bob creates a fulfillment obligation. And this obligation abstraction is actually just a thin wrapper around EAS. So we have some obligations that are active, as in you do something like transfer tokens to somebody, and then you get an attestation affirming that you did so. But in this case, this string obligation contract is just for submitting data on chain that's not necessarily going to be used by other contracts. So for example, if you do a job and then just host it somewhere on a server or on IPFS and you just need to report where it is on chain, then this is an easy way to just get an attestation that contains the data. And here we can see the fulfillment UID you get back is just an EAS attestation UID. So you can just get the attestation from it, which will be something attested by the obligation contract with you as the recipient. And then we use the ref UID here to prevent double spending and to prevent you using one fulfillment to collect an escrow that it's not for. So for example, you could try to fulfill an easier obligation and get a high validation score for that, and then try to claim a bigger escrow than you should have been able to. But this ref UID prevents that. So here Bob requests validation for his fulfillment from Charlie via the ERC-8004 validation registry. And in this case, we're just using the EAS attestation UID directly as the request hash because it works as an identifier for the fulfillment. And maybe this is misusing the request hash, and I would like to know if there's a better way to do it, but it works as is. And so Charlie validates with a validation response here of 75, which is greater than the demanded 50. And so Bob is able to collect Alice's deposit from escrow. And then we have a failure test too. So in this case, Charlie validates with only a score of 30, which is below the demanded threshold. And so Bob would not be able to claim Alice's tokens from escrow. And so he could try again. And in this case, it doesn't have to be Bob, so somebody else could try again as well. And if nobody is able to claim the escrow before it expires, then Alice gets to reclaim it. So a bit more about what I said about it doesn't have to be Bob. So actually, you could specify in a deal that it does have to be Bob. And that works because the validations in the system are actually composable. So we have a set of Arbiter contracts that just do very small, simple on-chain checks, like who's the recipient of this attestation, or like was it done before this deadline? And the Arbiter interface is very simple. It's just a function from an EAS attestation and demand, and the counteroffer, as in like what escrow does this correspond to a bool for whether it's valid or not in that context. And so you can use this to implement simple on-chain checks, or you can use it to like wrap things like the ERC-8004 validation registry as we did here, or to implement any more complex mechanism. And we have a set of compositional arbiters that let you say, like, I want all or any of a particular set of these arbiters to all be valid. So for example, if you wanted to say, like, I want this validation from Charlie above the score, but I only want Bob to fulfill this job, you can say that via the all arbiter and composing the demand here with a demand that only this particular person can fulfill your job. Or you could say that, like, I want this validation, and then only one of this set of people can fulfill my jobs. So there's a lot of possibilities here. And we have SDKs to the set of contracts in Python, TypeScript, and Rust. And the ERC-8004 arbiter isn't supported in those yet, which is why I'm just showing the solidity here. But that'll be there very soon. And also, let me just show the test passing to show that like these contracts are real and not just vibe coded solved. So yeah, and so yeah, they all work. Thanks.